Welcome to Beyond the Brackets. In this video, we continue our discussion on particular integrals focusing on type 5, where a type 2 function is multiplied by type 3 function. In other words, the expressions sin ax will be multiplied by x or cos ax will be multiplied by x. Here we consider sin ax or cos ax as v. To solve such problems, we use this formula. Here comes the first question, which is in the operator form. To write the auxiliary equation, we replace t with m and equate the equation to 0 to get m square plus 2m plus 1 is equal to 0. The roots of this equation are minus 1 and minus 1, which are real and repeated roots. Complementary function for this is yc is equal to c1 plus c2x into e power minus x. To find the particular integral, take the reciprocal of the operator form multiplied by the RHS. Here RHS is x into cos x, which is the product of type 3 function and type 2 function. Therefore, this belongs to type 5. This is the formula we use for type 5. So, we get x minus, here f of t represents the operator form. So, f dash of t will be the differentiation of operator form with respect to t. We get 2d plus 2 divided by d square plus 2d plus 1 into, here v is cos x divided by f of t is d square plus 2d plus 1. We first solve this expression. Here cos x is type 2 function. For type 2 function, we replace d square with minus a square. Here a is 1. So we get minus 1 plus 2d plus 1, that simplifies to 2d. We know that d is differentiation, so 1 by d will be integration. So 1 by 2 is the constant that is written as it is. Integration of cos x will be sin x. Now the first term becomes x into sin x by 2 and the second term becomes 2 cancels out in the numerator and in the denominator. We get d plus 1 into sin x in the numerator divided by d square plus 2d plus 1 in the denominator. Again, we first solve the denominator. So, since sin x is type 2, for type 2, we'll replace d square with minus a square. Here a is 1. So, we get minus 1 plus 2d plus 1, that simplifies to 2d. Again, 1 by 2 is constant, 1 by d will be integration. So, integration of sin x will be cos x. Now that the denominator is solved, come to the numerator. Differentiation of cos x will be minus sin x plus 1 into cos x will be cos x. That is the particular integral. The general solution is given by y is equal to yc plus yp. Substitute both the values and that will be the solution for the first question. Moving on to the second question, we first write the operator form by replacing d by dx with t to get d square minus 1 into y is equal to x sin x plus 1 plus x square into e power x. To find the auxiliary equation, replace t with m and equate the equation to 0. We get m square minus 1 equal to 0. Roots of this equation are minus 1 and plus 1, which are real and distinct roots. Complementary function is given by yc is equal to c1 e power x plus c2 e power minus x. To find the particular integral, take the reciprocal of the operator form multiplied by the RHS. Here the first term of the RHS has x, that is type 3, and sin x, that is type 2. So multiplication of that will be type 5. Second term of the RHS has e power x multiplied by the polynomial, that will be type 1 into type 3, that is type 4. So we'll solve both the types separately. Solving the first term, since it's type 5, this is the formula we use for type 5. Substituting the values, here f of t is the operator form d square minus 1. So f dash of t will be differentiation of the operator form with respect to t, that will be 2d. Divided by f of d is d square minus 1 into v is sin x divided by f of d is d square minus 1. First we'll solve the outer expression. Since sin x is type 2, we replace d square with minus a square. Here a is 1. So we get minus 1 minus 1. That is minus 2. So x into sin x divided by minus 2. Minus 2 in the numerator and the denominator cancels out. So we get plus d sin x divided by d square minus 1. Again, we solve the denominator first. For sin x, which is type 2, d square will be replaced by minus a square, that is minus 1. So we get minus 1 minus 1 in the denominator. Now that the denominator is solved, coming to the numerator, differentiation of sin x will be cos x. Coming back to the second term, here it is a multiplication of type 1 into type 3, that is type 4. First we'll solve for the exponential function e power x, where d will be replaced by d plus a. Here a is the coefficient of x, that is 1. So replacing d with d plus a, we get d plus 1 whole square minus 1, which simplifies to d square plus 2d. Here d is common in both the terms, so we get d into d plus 2. 1 plus x square on the RHS is type 3. For that, we take the constant common. So taking 2 common, we get 1 plus d by 2. Taking the whole term to the numerator, we expand using the formula 1 plus d inverse, which is 1 minus d plus d square minus d cube plus so on. Here d is d by 2. Here RHS is 1 plus x square. For this, differentiation will be 2x and d square will be 2. And all the higher order derivatives will be 0. So we'll consider the derivatives only up to d square. So the expansion is reduced to 1 minus d by 2 plus d square by 4. Now 1 into 1 plus x square will be 1 plus x square minus 1 by 2 into differentiation of 1 plus x square will be 2x plus 1 by 4 into d square of 1 plus x square will be 2. Simplifying this further, we get e power x into 1 by 2d into x square minus x plus 3 by 2. Here d is differentiation, that means 1 by d will be integration. So e power 2x by 2 will be written as it is. Integration of x square will be x cube by 3, x will be x square by 2, and 3 by 2 will be 3 by 2 into x. The general solution is given by y is equal to yc plus yp. Substitute the values of both. Completes the solution of the given question.